Hey friends, today is 15th of September 2020 and we are in somewhat a opening up phase of COVID-19 lockdown. I am compiling this discussion on orientation in the incredible multibeam systems and the factors influencing its image compilation. There is no concrete convention on sonar specifications for resolution and accuracy. Hence, it might be confusing and in very rare cases a little misleading too. So let's begin with the multibeam geometry and trigonometry. The four things of consideration here are the water depth, swath angle, slant range and the swath width. Swath width is a function of depth and the swath angle. It is influenced by the number of beams being transmitted per ping. Each beam is defined by the along track and across track footprint size. The footprint size itself is the function of beam width, range, beam angle and the seabed gradient. To put it in perspective, in a cross mills multi-beam, 128 degree swath angle provides 4 times the across track coverage of the water depth. For instance, Reson 7125 has 256 channels and can be selected for up to 512 beams per ping. The number of beams are independent of the channels. The multi-beam electronics can easily provide for much more number of beams per ping, but it is limited by the data transmission and its processing capabilities. Now let's assume that the speed of sound is 1500 meters per second. If a range is 75 meters, the optimum attainable ping rate would be around 10 pings per second. For the data that's coming through the cable, in the older days there was a limitation of cable for data transmission up to 10 Mbps. So the resolution did not actually match the ping rate due to the cable data handling limitations. The maximum cable length between the transceiver to the sonar processor is in between 15 to 30 meters. It is of particular importance that 75 ohm impedance is maintained throughout. For newer systems, the uplink between the transceiver unit and the sonar processor is a digital data stream of 38 Mbps or even more. In Reson 8125, the uplink data frame consists of 512 bytes transmitted at a frame rate of 7.5 kHz. On screen, a higher frame rate produces a smoother video and a high-end video graphic card is required. Otherwise, all the talk of resolution won't amount to much in terms of the visuals. Now, for data transmission, there is a analog digital conversion. The voltage generated for each channel is digitized. These digital signal characteristics are defined by the analog digital conversion sample rate. Reson 8000 series uses a 8-bit sampling, while the Reson 7000 series uses 12-bit quadrature sampling and has a sample rate of 34 kHz. So, for a data acquired on the same seabed with the same ping rate, quite obviously 12-bit quadrature sampling will provide a better resolution than a 8-bit sampling.